Today we're going to talk a little bit more about probability. For any random phenomenon, each trial generates an outcome. An event is any set or collection of outcomes. The collection of all possible outcomes is called the sample space, denoted with an S. When outcomes are equally likely, probabilities for events are easy to find just by counting. When the k possible outcomes are equally likely, each has a probability of 1 over k. For any event A that is made up of equally likely outcomes, the probability of A is equal to the count of outcomes in A divided by the count of all possible outcomes. The first three rules of working with probability rules are make a picture, and make a picture. The most common kind of picture to make is called a Venn diagram. We will see Venn diagrams in practice shortly. When two events A and B are disjoint, we can use the addition rule for disjoint. Disjoint is the same thing as mutually exclusive, which means that two events cannot happen at the same time. The probability of A or B is equal to the probability of A plus the probability of B. However, when our events are not disjoint, this addition rule will double count the probability of both A and B occurring. Thus, we need the general addition rule. The general addition rule is for any two events A and B, the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. The following Venn diagram shows this situation. You can see that we have A and B here in the middle, and that A and B are being double counted because they're both in B and in A. If A and B are disjoint, or mutually exclusive, then the probability of A and B is equal to 0. As you can see in this Venn diagram, they have nothing in common. Let's take an example. A survey revealed that 34% of people are entertained by reading books, 47% are entertained by watching TV, and 19% are entertained by both books and TV. What is the probability that a person will be entertained by either books or TV? Now, the word "or" is your clue that this is the addition rule. So the formula is the probability of books or TV, which equals the probability of books plus the probability of TV minus the probability of books and TV. Probability of books is 0.34, the probability of TV is 0.47, and since this is not mutually exclusive, we have the probability of books and TV, which is 0.19. So our answer will be 0.62. When we want probability of an event from a conditional distribution, we write the probability of B with a vertical line here, A, and pronounce it the probability of B given A. A probability that takes into account a given condition is called a conditional probability. To find the probability of the event B given the event A, we restrict our attention to the outcomes in A. We then find the fraction of those outcomes B that also occur. So the probability of B given A is equal to the probability of A and B divided by the probability of A. In other words, the probability of both events occurring divided by the probability of the given occurring. Note the probability at A cannot equal 0 since we know that A has occurred. Take an example. You draw a card at random from a standard deck of 52 cards. Find the probability that the card is a diamond given that it is a queen. So we're looking for the probability of a diamond given a queen, which is equal to the probability of a diamond and queen divided by the probability of a queen. So there is 1 out of 52 diamonds that are queen, called the queen of diamonds, divided by 4 out of 52 because there are 4 queens in the deck. So solving this, we get 1/4, which is 0.25. The table shows the political affiliation of voters in one city and their positions on stronger gun control laws. So we have a table of favor or opposing stronger gun control laws and whether they're Democrat, Republican, or other. What is the probability that Democrat opposes stronger gun control laws? We're looking at the probability that you oppose given that you're a Democrat, which is equal to the probability that you oppose and are a Democrat divided by the probability of being a Democrat. Probability that you oppose and are a Democrat is 0.16 divided by the probability of being a Democrat, which is 0.38, and that's equal to 0.421. When two events A and B are independent, we can use the multiplication rule for independent events. The probability of A and B is equal to the probability of A times the probability of B. However, when our events are not independent, this multiplication rule does not work. Thus, we need the general multiplication rule. We encounter the general multiplication rule in the form of conditional probability. Rearranging the equation in the definition for conditional probability, we get the general multiplication rule. For any two events A and B, the probability of A and B is equal to the probability of A times the probability of B given A, or the probability of A and B is equal to the probability of B times the probability of A given B. Let's take the following example. 65% of students at one college drink coffee, and 12% of people who drink coffee suffer from insomnia. What is the probability that a randomly selected student drinks coffee and suffers from insomnia? So we're looking at the probability that they drink coffee and have insomnia, which equals the probability that they drink coffee times the probability that they have insomnia given they drink coffee. So it's equal to 0.65 times 0.12, which equals 0.078. Another example. You are dealt a hand of 3 cards, one at a time. Find the probability that your third card is your first ace. So you're looking for the probability that the third card is an ace. So what must happen is that the first 2 cards you get are not aces, and then the third one is your first one. So the probability that you don't get an ace is 48 out of 52. Probability that you don't get another ace is 47 out of 51, and the reason being is that there's one less non-ace as well as one less card in the deck, times the probability that you get an ace, which is 4 out of 50 because there's 4 aces and there's only now 50 cards in the deck. This is equal to 376 over 5525, which is equal to 0.068. You are dealt a hand of 3 cards one at a time. Find the probability that you have at least one red card. So to find probability at least one red card, what we're going to do is going to do the complement, which is 1 minus the probability that you have no red cards. So to find the probability that you have no red cards is 26 out of 52 times 25 out of 51 times 24 out of 50. Again, you're not replacing the card, so you have one less card in the deck each time. So this multiplication gives you 2 out of 17. We're going to take 1 minus that, which will give me 15 out of 17, which equals 0.882. In this text, we use the notation the probability of A or B and the probability of A and B. In other situations, you might see the following. The probability of A union B, which is the same as the probability of A or B, or the probability of A intersection B instead of the probability of A and B.